Hello everyone, welcome to the modern networking lecture series. This is lecture number 8. So we'll be just continuing with the topic SDN and NFV. We started at the end of lecture number 7. Now we start with the background and motivation for SDN. Okay. Although we have covered this topic with respect to the big data and IoT, etc. So this is just a brief revision about this. So the background and motivation for SDN. So evolving network requirements. So we see that these are the three factors which actually contributed to the SDN. Okay, so this way we can say the driving forces, that these are the three factors, okay, which can be the driving force, or can we say the motivation for SDN. So the following trends are driving network providers and users to reevaluate traditional approaches to network architecture. The first one is the increasing demand. Now these are the trends with respect to the increasing demands. Okay, the first one is the cloud computing. So we see that there has been a dramatic shift by the enterprises to both public and private cloud services. So most of the enterprise networks, they are switching, and enterprises, they are switching to the cloud networks. Then the next factor contributing is to the increasing demand is the big data. Now big data actually requires processing of huge amount of data sets, and we require massive parallel processing is required between thousands of servers, and because of which not only the vertical, but we have to handle a large amount of horizontal traffic as well between the servers themselves. Then we have the next, number 3 is the mobile traffic. Now it is seen that many employees, they are increasingly using the mobile personal devices such as smartphones, tablets, notebooks, etc. So this particular devices, mobile devices, they support sophisticated applications. So they generate and consume large amount of image and public and video traffic. So this is also one of the contributors. Then we have the IoT, Internet of Things. So most of the things, so it is seen that in this particular IoT, many devices, sensors, they are connected to together. Okay, so that because of it they generate traffic. Okay, and some data is also shared. Also, although one sensor, it may generate very less traffic, but considering large number of sensors, maybe thousands of sensors, collectively they can generate large amount of traffic. So this was the increasing demand. Next we come to the second factor, this increasing supply. So as the demand on the network is rising, as we saw before, so the capacity of the network technologies to absorb rising, they have to absorb the rising loads. More and more number of large number of traffic is generated, so the network, they need to absorb those traffic. So the key enterprise wired and wireless network technologies which we saw in the first few lectures, that is Ethernet and Wi-Fi, they are running in the gigabit per second range. And then we also have the cellular networks, that is 4G, 5G, they are having a large capacity. So with this increasing supply, not only the devices but also the techniques, they are becoming more and more faster and with large capacity. So the increase in the performance of the devices, having larger and faster memories, and the devices, they have greater buffer capability, and we have faster buffer access as well as faster processor speeds. So they are contributing to the increasing supply. Then the third factor which we will see this is the complex traffic patterns. So complex traffic patterns are generated as compared to the previous traffics which we had before this big data, cloud computing, etc. So the first one is the horizontal traffic between the servers. So as we see in case of big data, the servers, so we not only have the vertical traffic from servers to the clients and clients to the servers, but there is a large amount, tremendous amount of traffic is between the servers themselves, that is a horizontal traffic. Then we have something called as network convergence techniques, where voice, data and video traffic, they are created and they generate some unpredictable traffic patterns. Then we have unified communication strategies, which involve heavy use of applications that triggers access to multiple servers. Then we have the heavy use of mobile devices. This mobile traffic is becoming increasingly significant fraction of enterprise network traffic. So more and more employees, they are using this mobile devices. Okay, and then we have the widespread use of public clouds. Okay, so in the recent years, more and more people, more and more we have large number of subscribers for the public clouds. Then the practice of application and database server virtualization. So these are the factors which contribute to the complex traffic patterns. Then although we have these things, but whatever traditional networks we have, they are unable to cope up with this particular complex traffic. So there are some limitations with respect to the traditional network we have architectures. So therefore we need to switch to the modern networking. So the limitations of the traditional architecture, the first is the static and complex architecture. Okay, so what we see in this case, the first one is the static and complex architecture. Now with the demand and the traffic increasing every day, so we need different levels of quality of service requirements. Then we have high and fluctuating traffic volumes, and they require different security requirements and network technologies, and these things, they are difficult to manage with the traditional architecture. Okay, so this particular traffic is very much complex and difficult to manage. So if we want to make we want to add some networks, or maybe like removing some devices, it becomes too much complex to manage those things with the traditional network. Then the second thing is the inconsistent policies. Okay, so suppose we want to make some changes, like if when we are using the access control list, so using the access control list, we can either deny or give access to some services. So suppose we want to change the policy, then that policy change must be implemented at every node. Okay, so if suppose we want to implement or change a policy in a particular network having hundreds of nodes, then it will become too much tedious, too much complex and too much time consuming doing it at every node. So this is one of the another drawback. Then inability to scale. Now with the demands which are growing rapidly in terms of volumes and varieties, then more and more switches are being added, so it becomes difficult to scale the network. Okay, so because with the increased use of virtualization and multimedia applications, when we have traffic patterns which are unpredictable, so it becomes difficult with the traditional network to scale the networks. Then the last point, as we see, the vendor dependence. Okay, so now with different new technologies being added, the devices, the nodes which we are using, maybe like if we have a router, those router, they are they must be configured according to the vendor. Suppose we are buying a Cisco router, so Cisco, we have to follow the instructions of the Cisco. We don't have some open source programming such things. So the devices which we are using, they are vendor dependent, and they cannot be used for some new techniques or new services. So these are some of the limitations with the traditional network architectures. So now we switch this is the reason that we are switching to the SDN approach. Okay, software defined networking approach. So these are the requirements we can see with respect to the modern approach. So the first is the this all the requirements are with respect to the SDN. So the first one is the adaptability. This is one of the requirement with respect to SDN. So this adaptability, it requires that the networks must adjust and respond dynamically based on the application needs, business policies and network conditions. So networks, they must respond, they must adjust themselves, they must have this capability to adaptability, with respect to the demand. Then second is the automation. So in case of automation, what we see is that whatever policy change we are making, okay, that must actually propagate throughout the network without requiring any manual interference. Okay, so if there are hundreds of nodes, we don't need to make changes in each and every node. That change must propagate throughout the network, so it becomes easier for us to make any policy change. Then the third point is the maintainability. Okay, so if we want to introduce some new features or new capabilities, maybe like software upgrades or some patches, it must require minimal disruptions of the operations. Okay, it should not be that we have to shut down the operation totally and then we have to make the change. It should not be happen in that case. So with minimal we can say disruption in the operation, that must be carried out. So it must be carried out, whatever is the maintainability, it should be done very easily. Then model management. So the fourth point is the model management. So we see that in network management software must allow management of the traffic at model level. It should not be at the individual elements level. So suppose we want to manage the network, that management must be done at the model level, not at the node level. Okay, then the next point is the mobility, which must be which is a required feature. So this whatever control functionality whatever we are implementing in SDN, it must also include the mobile users and also the virtual servers. Okay, that is the requirement. And the next one is the integrated security. Okay, so security must be a part of this SDN approach. We should not have like we have to give security, we have to add more layers for that. So security must be a part. Okay, it must be integrated in this. Okay, then on demand scaling, the last point. So whatever implementations we are doing with respect to SDN, they must have the ability to scale up or scale down the network, or its and also its services to support on demand requests. So these are the requirements of the SDN approach. This is the SDN architecture. Okay, now this is a comparison. This diagram gives a comparison between computing and the modern networking, as we can see. So on the left side we can see this part, which I am marking now, this part. So on the left side we have a modern approach in computing. This just gives a comparison how we implement the SDN. So here on the left side we have a processor. Okay, this processor can be from any manufacturer. Okay, previously what it was that if we are buying a processor from a particular vendor, then we have to use the software of that vendor. We cannot use any other things. Okay, applications, whatever applications we want to run on that particular processor, they are vendor dependent, they may or may not run. Okay, but now with the virtualization concept, what we have is we have this processor. Okay, and then we have some open interface. Okay, and here we can run any of the operating system using the virtualization concept. We can use any of the operating system. Then we have another open interface, and we can use any of the application which can run on this particular system. So same approach we want in the modern networking technology. So here what we see in this case, we have a switching hardware. This can be from any vendor. So this we can say it is a generalized hardware. Maybe it can be a switch, it can be a router. Then we have an open interface. Okay, and between this two open interface we have this SDN control plane. Okay, it may be open source, it may be proprietary. And then we have this again interface, and here we can run varieties of applications. So the main thing here is that whatever applications, they must be like vendor independent. Okay, they must be hardware independent. Okay, the concept which we are using in case of the virtualizing concept which we are using in this modern approach of computing, the same thing should be used here. So we have don't have a proprietary hardware, we have a general hardware, and any application can run on this particular hardware switches or any other node. And here we have this SDN control which provides the required functionality. Okay, we'll see this interface, what type of interface we need. Okay, and then here there is a comparison between the traditional and modern networking. So on the left side, this one, just marking it. So this is the traditional networking. So here we see that whatever the switch or the routers, they have both the plane working on the same node. So here we have the control plane and we have the data plane. Control plane, it takes the decisions like routing and any other such decisions is taken by the control plane. Okay, then a data plane, it just forwards the packets. So both the functions are implemented at the switch level. Okay, both the things, they are implemented at the switch level. This is the traditional networking. But in case of modern networking, we have some different thing, like in this case the data plane is separated from the control plane. Okay, at the data plane we have generalized switches. Okay, we have the switches, they only do the forwarding function. Then we have the centralized controller. Okay, or we can say SDN controller. So this blue one is the control plane. All the decisions, they are taken by the controller. Okay, and they are passed on to the switches. Okay, so this dotted lines, this is the communication path between the switch and the between the controller and the switch. And this solid line, this is the communication part with the switches themselves. This is where the packets are forwarded. Okay, so here we see that we have a centralized approach. Okay, this is the distributed. In this case we have a distributed approach. Every switch has its own controller, but here one controller, it can control a number of switches. So this is the flavor. This is what we have in case of SDN, and we'll study this in more detail. Okay, so we'll study this in the more detail in the next coming lectures. So that's all for this particular session. Thanks for watching.